So first, let me talk about the advantage of flow field algorithm. So different from A star, the flow field is always taking fixed time for no matter how many game objects you are trying to do pathfinding. So for example, maybe a flow field is taking 2 milliseconds if you are doing pathfinding for only one game object, and it's also taking 2 milliseconds for even 1,000 or 10,000 game objects. No matter how many game objects you want to do pathfinding, as long as they have a same target, the flow field algorithm will always taking fixed time. And this is how flow field work. Basically, divide map into grids, and this tile mapping has already done this for us. So, and if you are not doing tile mapping or you are doing something, you're making a 3D game object, you need to divide a game into grids manually. So, for example, you gotta have a grid length. Maybe a grid length is usually a terrain is 1,000 times 1,000. If you're taking maybe a 10 grid length, then you gotta divide the terrain into 100 times 100. And the flow field algorithm has three main fields, and I usually store them in arrays. So the first one is cost field. The cost field indicates the cost of go to a current grid. So we can see below the leftmost one is the start and end. The top left one is the start point, and the bottom right part is end point. The black part here is an obstacle. The cost field we can see here. For every block except the obstacle is only taking one. It only costs 1 to go to that block. For obstacle one, you're gonna taking 5535. It doesn't matter what's the number here. You just need to make sure you put a really large number here. And the second field is the integration field. The integration field indicates the cost from current grid to the target grid. So we can see in the second one. So because the bottom right one is the target, so the integration field, the integration value of it is 0, because you're starting from target is always 0. So, and this one and this one is 1 because we're using target and add the cost field of these two blocks. The cost field in the integration value of target is 0, and the cost field of this one is 1. So 0 plus 1 is 1, and same for this one. 0 plus 1 is also 1. And for this one, because it's an obstacle, so its cost field gonna be 655.35. So we using 0 plus 655.35 is still 0. And for this one, is the cost field of it is 1, but the integration value of it is, the previous one is also 1. So 1 plus 1 is 2, and same for this, 2 plus 1 is 3, and for this, 3 plus 1 is 4. But why we don't use this one? Why we don't use this block? Because it's too large. We're doing 355.35 plus 1. It's gonna be 655.36. It's far larger than just 2 plus 1. So we're always taking the smallest value when we are calculating the integration field value. And the last one is the flow field. It indicates what is the next correct grid to go. So we can see in this one. So basically, for example, on the top left one, because the neighbor of it are the integration value of the neighbor of it, so are 3, 3, and 6, 55.35. We're picking the smallest one, so there are 2 straight. So it doesn't matter which one we are picking. So we just pick this one. So the arrow is pointing to this one. And for this one is the neighbor are 4, 3, 6, 55.35, 1, 2. But actually this one should point to 1. Sorry. Yeah, but I guess you got what I mean. So we can see in this one, it doesn't matter. So it doesn't matter where the start point is. Every time we run a flow field, it will generate where to go for the entire map. So no matter how many units, no matter where you are, as long as you run a flow field, you're always taking fixed time. That's the reason. So let's see how to generate a cost field. So the cost field basically is traversing the current tile map, and because as we said, we are using tile map, but if you are not using tile map, you're probably gonna do some recast for finding obstacles. So because we are doing tile map, we just need to input the coordinate of each block of each tile. If the input vector 3 have a tile, then we just set to 1. Or if you want to make some road harder to get past, maybe for example you want to make a sand road. Maybe the car driving on sand road is gonna decrease the speed. You can make the sand road cost maybe set it to 2 or 3. You can make it higher. And if the vector 3 return null, it means there's no tile on there. So if the vector 3 return, if the input vector 3 return null, then it means there's no tile in the given coordinates. So we just simply giving it a really large number. So in this slide, we're giving it 655.35, and that's what we're gonna use in the later workshop. So let's start doing it. So open your Unity, create a new project. Remember to use a 2D project. I just name it Pathfinding Workshop. You can give whatever name you want.
Just wondering if there was a specific reason why exactly that number.
No, it's not. There's no specific reason. But remember, do not use the maximum value of the integer, or do not use any value that approximate to the maximum value of integer. As long as you are using integer array for cost field, or integer array for integration field. If you're using long, you can use maybe int max value, but if you're using integer, do not use it. Because in the integration field, no matter, we're not gonna consider if it's an obstacle, we're still gonna generate the integration value, no matter if it's an obstacle or not. So if you are using a maximum value of integer, you're gonna have an overflow if we add any number to it. Alright, we're gonna keep going. So open your downloaded assets and copy the package out. And then you can directly drag the package into the assets here. Then let's open the things in the package. Just directly drag the thing into a hierarchy and delete, remove the current thing. Okay, remove thing. So you can see there's something we make here. And at first step, make sure you disable the card here, because the card requires something from the flow field class, but the flow field class is not finished yet, because we're gonna finish in the workshop. So you can hit this box here to disable it. And you can see there's some weird road here. Because we're gonna try to do some change. Because we're gonna make sure our pathfinding is generated the correct path here. And after introduction, we can just go into the flow field class. So in the flow field class, we can see this code. And there are some code like this. This code are just making sure there's not gonna be any error here. So there's not gonna be any error in the card control script. So we can just leave them here for now. But for now, the first thing we're gonna do is we're gonna use another library. So using Unity engine dot tile maps. If you are not using tile maps, we're not gonna do any coding about tile maps here. So then after we do this, we can create a new tile map here. No, not a new one, just create a tile map variable here. Oops. And if we go into the scene, we can see the flow field class is attached on the grid. And the tile map we're going to use is the second child of the grid. Really, it's going to be the tile map we are using today. So how do we get a second child of the gamma object? What we can do is like this. Transform.getChild. So because same as the array, the child index is start from 0. So we want to get a second one, you're going to input getChild1. Then we can get a transform of the second child of the current gamma object. Then we need to get the tile map components from the gamma object. So what we can do here is get components tile map. Then after doing this, we need a cost field. We're gonna do integer array for cost field. So right now we have a cost field, but how do we know what's the size of the cost field? How do we know what's the size of the cost field? So there's a variable in the tile map called local bounds, and first we need to know what's the bottom leftmost index. So we're gonna do integer start x and start y. So there's we can just do start x equals to tile map or local bounds. The mean means the mean just return us a vector 2 that has, is it vector 2? No, it's vector 3. It return vector 3 that has the smallest x and y value in the tile map. Oh, sorry, what's the question?
Try to control scroll.
Oh.
It will zoom in the screen so we can read the text.
Sorry. The main basically returns the vector 3 that has the smallest x and y value in the tile map. So start x is gonna be a mean.x. Oops, wait, this because it's gonna return vector 3, and in vector 3 everything gonna be float, but those we can know everything in the tile map are they are integer, so it's okay to directly transfer it to integer. Same as start y. The next step we're gonna get its width and height. So there's another value in the tile map local bounds called extends. Basically, it's gonna return a. Let me check what's is that vector 2 or vector 3? Okay, still vector 3. It's gonna return a vector 3 that indicates the half of the width and height of the current tile map. So y is gonna be because it's half, so we need time 2. Oops. height. But remember, if we're doing this, because we're gonna use this two as the size of the array. But if we are doing this, we're gonna find that the topmost and the rightmost are not the topmost line and the rightmost line are not gonna be accessed. For example, in here, this line and this line are not gonna be accessed here. So what we're gonna do is we simply plus 1 here. So now we have a width and height, but you guys can see the cost field is a one-dimensional array. How do we transfer a size of two-dimensional array to one-dimensional array? The way we do is just simply time them together. And then we're gonna try to generate the cost field. For this one, we need a two-dimensional loop, a double loop. So the way we're gonna do it is like, remember we say we can input vector 3 to get if there is any tile in the input coordinates. So we can do this. There's a method called getTile. That's the place we can input the coordinates. Because we're gonna add our x and y value to a start variable. So we just do I plus start x and j plus start y. And the third value always gonna be 0 because it's for 2D. It's for 3D it's for 3D it's not gonna be 0, but for 2D it's gonna be 0. And if this one return null, we're gonna set the cost field to 655.35, and the way we transfer two-dimensional coordinate to two-dimensional index to one-dimensional index is like we times the x value to the height and plus j. If it's not return null, we're gonna do just simply set it to 1. Then for doing this, we can just generate a cost field. So right now we can do some check for it. The following are not mandatory, but you guys can do it if you guys want to check it. I'm gonna leave some time for now to make sure you guys can copy everything. So right now what we're gonna do is I'm gonna write a debug code for what we are doing right now. So first off, you guys don't have to do this, but if you guys want to verify the result, you can do it. You can do this. The way we split one-dimensional coordinate into two-dimensional index is like for x part we we use the index divided by the height. And for y, we use the index mod the height. So let's see what our code is doing here. Okay, I gotta go into a project. So we just simply drag the marker here, drag the marker to the gamma object, and then we run it. Damn it, I forgot one thing. Yeah, if we're doing this, it should return the correct value, correct result. Yeah, it looks like we do have a correct value here, but we can see those cards are a little bit bottom left to the correct position. So when you do is if we add 0.5 to each of the coordinate, you're gonna be in the correct position. But we already know we are doing good, so we should comment this part right now because it's just for debug. So next step we're gonna talking about generate the integration field. It's really hard to explain how to generate an integration field in a few sentences. So I just write step by step here. So for initialization, we set all integration value to infinity. But there's no infinity in C#, so we just set it to integer max value. The reason we're doing this is because we hope no matter what value is the first come in, we always set it to that value. But in the later we're gonna compare to the later value to find the smallest one. But for the first one, we always take it. And then we set the target integration value to 0. Then push the target to the Q. Because we are starting from the end. The target we started from the end, so the end should be initiated to 0. And the while loops when the loop is not empty, the while loops we're gonna end the loop if the Q is empty. And for each while loop we're gonna pull the first variable while in the queue. The pull basically means get and remove. And for each value, we got all the neighbor values for the current value. And then we check the neighbor values in integration value, and then compare to the cost to its cost value plus the current integration value. If we found the cost field of the neighbor plus current integration value is smaller than the neighbor's integration value, then we update it. And then if we check if the neighbor is in the queue, if it is not, we just push it to the queue. Here's the pseudocode, but we actually don't need to take a long time in the pseudocode because we're gonna actually code it. So get back to our C# code here. We don't need an update here, so we just delete it. Before doing that, we're gonna have a new method called reset integration field. And we also need a global variable is an integer array called integration. And in the reset integration field, we just first we initialize the integration field, integration array, I mean. And we also write a loop we use this loop to set all the integration value to maximum value of integer. The way we get a maximum value of integer is like we do int.max value. Oh wait, forgot index. After we finish this, we can start writing the writing the generation. Because for integration value, we need to take the n coordinates. So we do like the 3 ends. And in this one, we first have a current variable. Current equal to n.x minus, oh wait. Because the n.x is an actual coordinate in the map. It's an actual vector in the map. But we need to transfer it to absolute value. So we just do n.x minus .x and times height plus same as n.y, we do n.y minus .y. Then we initiate the queue. The queue is including the system.collection.generic, so we don't need to include using any actual library for the queue. So first step, we push the current to the queue, and for queue, the push is in queue. Oh wait, remember we need to run the reset integration field before we run everything. Then we set the integration value of the current to 0. Then that should be all for the initialization part. I'm gonna wait here for a few minutes for you guys to copy it. So next step, we need to do the loop. Because we do like if open set is not empty, which means open set count is larger than 0. So we do current equal. So the power method in queue is dq. Because queue is a first in first out data structure. So which means the first the first value you put in the queue gonna be the first one gonna be the first one to pull. So basically the queue is like, for example, there's an integer queue. We just call it queue. It's an integer queue. We in-queue something. For example, we in-queue 1. So the queue gonna be 1. Then we in-queue 2. The queue gonna be 2. The queue is more like a linked list. So if we dequeue something, the one gonna be the output. So maybe, for example, we dequeue, we just print the dequeue. We're gonna print 1, and the one just gone. Yeah, and you will do the same thing. You're gonna print 2 here, and 2 is also gone. For current one, we do DQ, and then we need a method to get neighbor. The list is also including the system.collection.generic. So it's the same library as the queue. And the list is really like a real list in Java. So what we're gonna do here, sorry, can I have the marker again? So we know for each block, it's gonna be something like this. The middle one is the current one. The neighbor, those around it is a neighbor, So for this workshop, we only need this 4. We only need these 4 directions. If you are doing yourself, you can get 8 directions, but for this one, we only need 4. So what we're gonna do here is like, first we have a double loop. Sorry. So we check. First, we check if I is equal to j. In this case, we're gonna exclude this 3 because we don't need the middle one either. And for a second one, we're gonna check is I minus j is the absolute value of minus j is equal to 2. Because we can see for this 2, the index gonna be, this one gonna be 0 and 2, and this one gonna be 2 and 0. So this 2, if we minus them together, they're always gonna be 2. And there's no other blocks in these 9 blocks fulfill these requirements. You have these 2 cases, you just do continue. And then we need another method because inbound, which take two integer value. We just check if these 2 values is in the bound, so which is in the range of x and y. So we do we just simply do this. If it's less than 0 or larger than y or y dot height, then we just return false. If it's not, we're gonna return true. Yeah, if it's all false, we're gonna return true because if one of them is true, it means that at least I or j is not in the range. We're gonna do if in bounds. If it's in bounds, then we just do result.add. We need to transfer I and j into actual value. So first one, because the reason we're doing this is actually we need to take. We're going to take one from these 4 cases. So which means the actual I and j gonna be -1 to 1. So that's why we're doing -1 here. So which means if I is 0, it's gonna be -1, -1. If I is 2, it's gonna be 1. So same thing as J. After everything is done, we simply return result. That's our get neighbor. That's our get neighbor method. So in this part, we're gonna have a list. This called neighbors. We don't need to initialize it because we're gonna simply do equal to get neighbor. So the value is current. And we need to check each neighbor, so we can just simply do for each. So for each neighbor, we just do if the neighbor's integration value is larger than the current integration value plus the neighbor's cost field. If it is, we're gonna let the neighbor's integration value equal to current integration value plus the neighbor's cost field value. Then we're gonna check if the neighbor is in the queue. There's a method of queue called contain, but let me show here. So openSet.contain. The queue have a search method called contain, but however contain really slow because it basically contains what contain do is like basically search all the value in the queue and see if it is equal to the given variable. If it is equal, it's gonna return true. If not the match, it's gonna return false. You guys can see this method is very slow. So but right now we know the what's the total amount of the variable we're gonna have. So we can do is have another variable here called bool. Well, actually, you can just simply define the method. It's a bool array. Called in openSet. Because for bool value and bool array, when we initialize it, its default value gonna be false. So we don't need to do something like a reset integration field to fill all the value of the bool array to false. Because when we initialize it, it's gonna be false by default. So when you do here, we add something in this line. So if it's in the queue, we're gonna set it to true. If it's not, we're gonna set it to false. So what we're going to do here is we're not going to do contain. We just simply check if in openSet neighbor is true. If it's false, this one gonna take in fixed time, so which is O1 time. Gonna be really much faster than doing contains. If it is, we're gonna push it to the queue, which is openSet the in-queue neighbor. And remember, we to update the in openSet. So that should be how our general integration field method here. That'll be how it looks like. I'm gonna make it smaller so you guys can see everything. You guys can see everything in there. I'm gonna leave a few minutes here for you guys to copy it. So right now we have our integration field. So let's take a look at the flow field. Basically, the flow field is we go over integration field and see what the smallest neighbor is. We find the smallest neighbor and we point. We just assume it's an error in the flow field. For each block, we point that arrow to the neighbor without having smallest integration field. So let's take a try. In here, we do generate flow field. We don't need to take any parameters for this one because we already know the end, kind of. So first step, we're gonna have a global variable here. This time it's not gonna be ints. It's gonna be vector three ints. The difference between vector 3 and vector 3 int is like vector 3 has its x, y, and z value are all floating points. Vector 3 int is x and y and z value are all integer value. And for generate flow field, we initialize the flow field variable. Oh wait, forgot says to array. Sorry. Let me check. Okay. It's here. The next step is we go through entire integration field. So what we can do here is we're still gonna do two-dimensional array here. So for each one, we need a smallest value. We need a smallest index and smallest value. Initially, we can set the smallest value to 0 and smallest index to 0. Wait, smallest value to maximum value and smallest index to 0. But before that, we're gonna check if this one is the starting point. If it's equal to 0, it means this index is the starting point. Then we just simply say the flow field of this index is gonna be itself. Actually, no, I'm gonna have a count value. Gonna be new vectors 3 ints and it's gonna be I plus start x, j plus start y, and 0. It's gonna be itself, and then just simply continue, because this might not be the last one. And if it's not a starting point, then I mean, it's not if it's not the endpoint. It's gonna be it simply sets smallest value to 0 and smallest value to maximum value. And still, we do a similar loop in the get neighbor. Still check if it's in bound. Oh wait, still check if x equal to y and or x minus y's absolute value to if it's 2. Then also check if it's in bounds. If it's in bounds, we're gonna wait in bounds. Wait a second. I think if I having. Oh wait, I'm sorry. I made a really serious mistake here. So basically, for here, I need to do the same one for get neighbor. So I made a really serious bug in here. Inbound is gonna be x plus I minus 1 and y plus j minus 1 here, because if we simply do I and j, it's always gonna be between 0 and 2, so it's always gonna be inbound. So sorry, that's a mistake. Sorry about that. So same 2 inbound here. So x plus I plus x minus 1 and j plus y minus 1. Also, we're gonna compare it to the smallest variable, smallest value. So we see if current, if it's larger than current. If it is, then we're gonna do smallest equal to current, and smallest value gonna be equal to integration current. Then after the loop, we just simply extract the trying to extract the coordinate from the index. So basically, what we do is like fulfill current. Wait, fulfill I times height plus j equal to just simply do this. So does anyone need more time to copy the code? Okay.
We'll make sure that the inbound is the same. So I was thinking if one of them had plus 1, the other had minus 1, but no, they both have minus 1.
Okay, I guess we're good to go. So then we finish this two. Then the last thing we do is we need to check, are we doing it correctly? we just simply have a public void generate. Wait, is it taking also taking access rate? Oh, yeah. That's the master how we generate something, and then we're gonna do a debug code here. Also, this step is also optional. You don't have to copy it. Okay. So you're gonna have 4 more global variables here. Oh, actually 3 more. They are up, down, and left. Because debug marker is already a right, so we don't need a right variable here. So basically, we just do a check like this. Oh, make sure it says else. You just gonna copy paste this line. Oops, actually, oh wait, no. Sorry, I made a mistake. What? Okay.
Oh, yeah.
Well, it's gonna be how our debug code looks like. So let's take a try to see if it's working correctly. I'm gonna leave a few minutes here to let you guys copy the debug code. Well, because debug marker is already a car, like point to right. Because debug marker looks like this.
Oh, debug marker is the car.
Yeah, it's a car.
Okay. Oh, and then we have up, down, and left for the car.
Yeah.
Oh, that's right. Because right, the default for right is.
Yeah. let's try it. Hope it works because I'm not entirely sure. Last time doing it got a really serious bug. Oh no, it's not. Let me check. Let me check what's wrong. Oh wait, I know the reason. I haven't said anything. Sorry, I haven't said anything. So that's the reason it's not generating anything. Wait, let me see what's the coordinate of the house. So it's 2, 5, and 0. 2, 5, and 0. Oh yeah. Oh wait, it's in the start. It's in the start. Oh wait, I forgot to say we better change start to away because the car is using start as the car control is using start as the first method. So if we are using start here, there's a chance that car control run before the script. I'm gonna produce an error. So we just change it to away. Then let's see what's gonna happen. Oh, I forgot something. Yeah, I just need to do like in the debug here, simply do cost field I to this one, and then we do continue. Wait, what? Oh, I do 36. Jeez, I got really bad memory here. Okay, we can see the car right now is pointing to where it's supposed to go, but there's a problem here. We can see in here the car directly goes up. Look, because the road supposed not connected here, so the car just goes up. So we need to find some way to fix it. If you take a look at the texture here, you can see I add some more collider to it. Add some collider to the side of the road. If you want to add a collider, you simply do drag. You just simply drag and you can draw it. Sorry. So how do we check if there are a collider between? Is there a collider on the side? You simply do some change in generate integration field. There are two more vector two variable here. First is origin. Second is direction. So for origin, that equal to wait, you know what? Like I gotta get 2 more because very annoying to do calculation about transferring index to coordinates. Origin equal to go back to 2 current x current y. Here in this, we're gonna do is the current x equal to neighbor divided by height plus start x. Current y equal to neighbor mod height plus current start y. And direction equal to new vector 2 current x current y. Oh wait, don't forget 0.5. Because there's a 0.5 difference between tile and the actual coordinates. And sorry, actually you should change current x and current y to float because the point y is the floating point. So direction is new vector 2 current x current y minus origin dot normalized. And then we add a new variable here. We call it collide. So every time collide are initialized as 0. And we also add collide in the calculation. And we do physics 2D because it's a 2D object. And recast. Origin, direction, and the length is gonna be 1. If it hits, we simply set collide to same as the obstacle value. Then that's basically what we're gonna do to detect colliders. So let's take a look back to the project. Yeah, we can see the car here is not going directly goes up. It turns right. So the car in this row still goes up and down because for this part they are all 636. Those costs are all 655.36. So going up and down still costs the least. So let's take a look what if we put the actual car on it. So back into our code, let's just simply comment out the debug code. And remember remember this method, we just change it to what it's supposed to be. Flow field, integration field, height, start x, and start y. And we'll go back to a project, let's activate the car. Remember the car we deactivated? Let's see what we're gonna do right now. Sorry, I said the car speed very slow, so I can just making sure I can see its behavior correctly. Yeah, so it looks like the car correctly goes to the endpoint. Yeah, so that's it. That's all for today's workshop. Thank all you guys for staying for the entire workshop, and thank you for attending.